Okay, so let's talk about this lesson. So we're going to talk about lesson 7, creating and solving quadratic equations in one variable. So for me specifically, this is applicable for Algebra 1 and my Algebra 2 students because there's a lot of quadratics involved, which are involved in both standards, and these are all in context. Let's talk about these standards. So the first standard you'll see here, let me zoom in a little bit. The first standard that we're dealing with, you'll see here, is A1ACDA1, which is to create equations and inequalities in one variable and use them to solve problems. And then the next standard that we're going to deal with is one that we might be a little familiar with, which is solve quadratic equations and inequalities in one variable. And we're going to solve quadratic equations by inspection, taking square roots, completing the square, knowing and applying the quadratic formula, and factoring. So in this particular example, they're expecting you to factor, okay? So the first problem we have here is this opening exercise, and it says the length of a rectangle is 5 inches more than twice a number. It says the width is 4 inches less than the same number. The perimeter of the rectangle is 44 inches. Sketch a diagram of this situation, and then find the unknown number. So pause the video and see if you can figure this out. Okay, so I'm going to assume that you did that. So we're going to go ahead and start this. So the length of a rectangle is 5 inches more than twice a number. Okay, so what I'm getting here is rectangle. I'm going to draw this nice little rectangle out. And right here, I'm going to let this be my length, and this is going to be my width. And then I'm just going to read the problem, kind of outline some of this. So it says, the length of the rectangle is 5 inches more than twice a number, okay? So twice a number, whenever you see a number or something like this in algebra, that's your variable. So in this case, we'll call it x. And it says the width is 4 inches less than the same number. So that same number, right, we call that number x. So this number is also going to be x. And it tells me the perimeter is 44 inches. Okay, so if I go back over here, what I've got is that the length is 5 more than twice that number. So 2x, and whenever we say more than, it's addition, okay? So even though it said 5 inches more than twice a number, right? You want to think about twice this number, so 2x, and then 5 more is addition, not multiplication. So it's saying it's adding 5 inches to it. And then the width is going to be pretty much the same. You're going to use the term over here, this variable first. When you think about something being less than, that's subtraction, right? If I'm 5'10", and you're 5'6", then I'm going to say you're 4 inches less than my height. Your height is 4 inches less than my height. So in this case, it's going to be x minus 4. So if I go over here, I can write in that width, and it's x minus 4. Okay? So since this is a rectangle, we know these parallel sides are going to be the same. So this length over here is x minus 4, right? And then this length over here is 2x plus 5. And then it tells me that the perimeter is equal to 44 inches, okay? So if this is the case, well, I can look up what the formula for perimeter is for rectangle if I don't know it. If I do know it, then I'm just going to write it out. So the perimeter for a rectangle is twice the length plus twice the width, okay? So 2 times width or 2 times length, or I just add up all the sides. That's the same thing. So I'm going to write this out. So this is telling me that my perimeter, P, is equal to 44 inches. And then it's also equal to twice the length. So 2 times parentheses 2x plus 5. And then 2 times x minus 4. And then I just distribute. So the next line, right, I've got 4x plus 10 plus 2x minus 8 equals 44. And then I start to combine like terms, so 4x plus 2x gives me 6x, and then 10 minus 8 gives me negative 2. And what I could do is solve this out. So I can add 2 to both sides. So I get 6x equals 42. And what this tells me is that x equals 7. So since I have the value of x, I've found the number, and I can find these side lengths, okay? So if I come up here and I plug in 7 in for these x's, right here I get 2 times 7, which is 14, and then 14 plus 5 is 19, so the length is 19, and then the width is going to be 3. Okay, so width is 3. And so I can check my work here, so my perimeter is twice the length, which is 19, plus twice the width, and it should come out to be 44. So 2 times 19, right, that's 38, plus 2 times 3 is 6, which is indeed 44 inches, okay? So don't forget your units. So 19 inches and 3 inches, and the reason why we know it's inches is because the original problem stated that it was inches, okay? So if I come back over here, let's try another one. It says the length of a rectangle is 5 inches more than twice a number. So, right, twice x, that number is x, plus 5. And then it tells me the width is 4 inches less than the same number. So this is actually really similar to the last problem. In fact, it's the same kind of lengths here, but the only thing that's different is now they're telling me the area. So it tells me the area of the rectangle is 15 inches squared and wants us to find the unknown number. Well, we can still do that. I'm going to go down here and I'm going to draw pretty much the same rectangle. And we said this side length is 2x plus 5, and this one is x minus 4, so it's the same setup, but the only difference is that the area is what we're looking for. So they tell us that the area, right off the bat, was 15 inches squared. Well, what this allows me to do is it allows me to set up an equation, right? So area is equal to length times width. Well, we have the length, we have the width, we're missing the x component of both of those, and then we have the area. So I'm going to write this out. So length, I can write length times width is equal to area. So that means 2x plus 5 times x minus 4 equals 15. Now, whenever you have a quadratic equation like this, you want to do one of two things. You either want to factor or you want to use the quadratic formula. And my students at this point, they haven't learned the quadratic formula. So what they're going to have to do is factor, okay? So anytime you factor, or anytime you use the quadratic formula, you want to set the quadratic equal to 0. Okay? So if I, distribute all this out, so 2x times x is going to be 2x squared. 2x times negative 4 is going to be negative 8x. 5 times x is positive 5x. And then 5 times negative 4 is negative 20, which equals 15. So I can combine like terms on the left-hand side, but remember we want to get the right-hand side equal to 0. So we're going to have to handle this 15. Okay? So if I want to get this 15 to the other side of the equation, if I want to move it to the left-hand side of the equation, it's positive over here, so to move it to the other side of the equal sign, I'm going to subtract it. I'm going to do that. So I've got 2x squared minus 3x minus 35 equals 0. And then I want to factor, okay? So if you remember the process of factoring, we're going to do a times c, which is negative 35. No, that's not true. Sorry. I was looking at the c term. I'm used to, we were factoring with a one was 1. So 2 times negative 35, excuse me there. So is negative 70. And then my b term is negative 3. Well, I can start to think about some of these factors, right? We just talked about 2 and negative 35, so I'm going to write that one first. Well, I'm going to do 1 and 70 first. So negative, positive, positive, negative. So this is negative, positive 69. So factors of negative 70. And then negative, positive 2, positive, negative 35 is going to equal, right, positive 33 and negative 33. And then, let's see, it's not divisible by 3. Not sure about 4. But I know it's divisible by 5, okay? So I'm going to try 5. So negative, positive 5, and then positive, negative 14 should be. So negative 5 plus 14 is positive 9. Positive 5 minus 14 is negative 9, okay? And then, right, we could divide it by 10, right? So if I divide this guy by 10, that gives me 7, so negative plus 7, positive, negative 10. So negative 7 plus 10 is positive 3, and then positive 7 minus 10 is negative 3. So this is this process of factoring that we did. So you should be familiar with that. If you're not, I encourage you to go back and look at factoring. I think that's lesson 3, okay, in this playlist. So if I go back, right, I'm going to split up this x term. So I've got 2x squared plus 7x negative 10x minus 35 equals 0. I'm going to group the first two terms and the last two terms. Remember to put that plus sign there. And then over here, I'm going to factor out x. And then over here, I'm going to factor out negative 5 is what the GCF in this parentheses is in these two terms. So that leaves me with 2x plus 7. So what's nice about this, right? Got 2x plus 7 factors out to the front. And then in the next parentheses, I write x minus 5 equals 0. And then I set each factor equal to 0. So if I take 2x plus 7 and I set it equal to 0, or x minus 5 equal to 0. And remember, we have to think about which one works in the context of our problem. So if you watched the last lesson, lesson 6, right, you're going to see that you can have an extraneous solution here. So if I subtract 7 and then divide by 2, I get x equals negative 7 over 2. And this is specifically inches. So it's saying x is this number, this missing number up here is negative 7 over 2 inches. But that doesn't make any sense because unless both these numbers up here are positive and they're more than what I need, they're not going to work out. And I think my screen went a little confused there. So let's see if it came to. And then over here, right, I can add 5 to both sides of this equation, and I get x equals 5 inches, and that makes sense. So right, negative 7 over 2, we call that extraneous. So in your terms, we're going to yeet it into the garbage. It doesn't make any sense in our problem. That's just going to go right into that garbage. Doesn't make any sense, so we're just going to ignore it, okay? And then we're going to take this 5 inches, and we're going to plug it back into our equation to find the side lengths, if it will load. We're going to make it load. Here. So over here, 2x plus 5, if I plug in 5, 2 times 5 plus 5 is going to be 15. So this side length is 15 inches. And then 5 minus 4 is going to be 1. Okay, so 15 inches times 1 inch is 15 inches squared. So right length is 15 inches, and then width is 1 inch. And then if you check your work, A is equal to L times W, and that does come out to be 15 inches squared. Okay. So math works. Okay. A picture has a height that is 4/3 its width. It is to be enlarged so that the ratio of height to width remains the same, but the area is 192 inches squared. What are the dimensions of the enlargement? Okay, so all we're doing is it's telling us, I don't know, I've got some weird Polaroid here. And on this Polaroid, I don't know. Let's see if I can do this. Yeah, that looks right. Some strange bearded man. That may or may not be teaching you math right now. Okay, so it tells me, okay, this is my image. The height is 4/3 times the width. And then here's the width. So, right, if we enlarge this, right, if I draw the exact same thing, but we enlarge it, and we put it on our wall, right? And I'm not going to go through the process of drawing that again, but if we enlarge this Polaroid, what we're saying is that it's going to be the exact same image, just enlarged. So this height is 4/3 the width. And then here's the width. So, right, the dimensions were enlarged, but the ratio between the two is the same. So if this is the new width, then this height is still 4/3 the width, okay? And they're telling us that the area of the new thing, the new picture, is 192 inches squared. So the entire area is 192 inches squared. So all we have to do is solve this out. Well, area is equal to length times width, so I can reverse that. And then right here, right, my length would be 4/3 W, or my height. Okay, same thing. So 4/3 W. It's not the same thing, but it is for area, right? We're doing the area of this Polaroid. It's this length, this side length times this side length. And then I've got W here, equals 192 inches squared. That's my bad. I did not mean to make that look like a G, but I cannot erase it for some reason. My Surface Pro does not like to erase. So W times W is going to be 4/3 W squared equals 192 inches squared. And then I want to get rid of this 4/3. And right, if you remember your operations of solving equations with fractions, you want to take and multiply both sides by the reciprocal. So those cancel out. 3's cancel out, and you get W squared equals 192 inches squared times 3/4. And over here, we can just quickly 192 divided by 4. So 4 up here, that gives me 16. 19 minus 16 is 3. And then 4 times what gives me 32? That's going to be 8. So 0. 48 times 4 is 192. So 192 divided by this 4 is going to give me w squared is equal to 48 times 3. Okay? And then I'm going to multiply this out. So 40 times 3 is 120. And then 8 times 3 is 24. So 120 plus 24 is 144 inches squared. Okay? So that's still inches squared. And then right here, I can take the square root of both sides. So I get W equals plus minus 12 inches. But 1 is not going to make sense in the context of our problem, right? The positive is going to make sense, but the negative will not make sense. Because this negative, right, if I plug it in up here, that's going to tell me, it's going to give me a positive area, but it's going to tell me my side lengths are negative. It's like you owe me a length. And that doesn't make any sense in the context of the problem. So whenever we write the final solution is we say that, right, the width is 12 inches, just the positive version. So if that's the case, I can say that the width is 12 inches over here, so we know this dimension. And then we can easily find this one, right? 12 divided by 3 is 4. 4 times 4 is 16. So this height is going to be 16 inches. So even if we don't know the original, if they give us a proportion, we can solve the new thing out. So I don't even know what this Polaroid would be. I don't know what these lengths would be, but they gave us the area for this one, so we had enough information to solve it out. So it says to solve the following problems. The length of a rectangle is 4 centimeters more than 3 times its width. If the area of the rectangle is 15 centimeters squared, find the width. So the length of a rectangle is 4 centimeters, then 3 times its width. So that's going to be 3w plus 4. So that's our length. It says if the area of the rectangle is 15 centimeters, find the width. Well, that's going to be pretty easy, right? Okay. Okay, so our length is going to be 3w plus 4, right? And then our width is going to be w. So if this is the case, and our area, right, they give us our area is 15 centimeters squared. Yeah, this is the case. What I'm going to do is I'm going to use that formula again. So area is equal to length times width. Okay, which means length times width is equal to area. So I can reverse an equation, and then I'm going to take my length, which is 3w plus 4, and then my width, which is just w, is equal to 15. And then I'm going to solve this quadratic out, right? This w will distribute. So if I distribute that w right there and there, I'm going to get 3w squared plus 4w equals 15, okay? So then, remember, whenever we're factoring these quadratics, we want to set this equal to 0. So I'm going to subtract. So I get 3w squared plus 4w minus 15 equals 0. And then I'm going to take a times c, which is negative 45, and in my b term, which is positive 4, and I'm going to find factors of negative 45 that add to be b, okay? So I'm going to factor negative 45. So let's see. Right, they're close in value because I've only got a positive 4 here for the b, and one of my factors has to be negative. So I know 45 is divisible by 5. So 45 divided by 5 is 9, so I've got plus minus 9 minus plus 4. So positive 9 minus 4 is positive. That's 5 minus plus 5. 9 minus 5 is positive 4. So here's our sum over here. So positive 4. And then negative 9 plus 5 is negative 4. Okay? So if that's the case, right, the two pairs that I'm going to use are positive 9 and negative 5 to split up this quadratic. So that gives me 3w squared plus 9w minus 5w minus 15 equals 0. So these first two terms I can factor out of 3w, so I'm left with w plus 3, And these last two terms I can factor out a -5, which leaves me with w plus 3. And we set all that equal to 0. So w plus 3 factors out. I'm left with 3w minus 5 equals 0. And what this gives me is, it gives me w equals -3 centimeters, which doesn't make any sense in the context of our problem because it's negative length. So I'm going to take 3w minus 5 and set it equal to 0. So I add 5 to both sides, so I get 3w equals positive 5, and then w equals 5/3 centimeters. So if I go up here, this length is 5/3 centimeters. And over here, if I plug in 5/3 in this, it didn't ask for the length, but we're going to go ahead and do it just to kind of see what it would be and check our work. So if I plug in 5/3 over here, 3 divided by 3 is 1. So I've got 5 plus 4, right? So I'm just using this expression. So I plugged in 5/3 here. 3's cancel. I'm left with 5 plus 4, which is 9. Okay? So 5/3 times 9. So area is equal to length times width. So it should come out to be 15. So we're going to check that. So the length is 9. The width is 5/3. So 9 divided by 3 is 3. So 3 times 5 is indeed 15 centimeters squared. So these two were centimeters. So centimeter times centimeter gives us centimeter squared. And that is how the cookie crumbles. Okay. So ratio of length to width in a rectangle is 2 to 3. Find the length of the rectangle when the area is 150 inches squared. So whenever you see ratio, here's all ratio means. Here's all that we're talking about. Okay, my one note disappeared, so I gotta put that up, but that's okay. If I have a rectangle, and I'm talking about a ratio of 2 to 3. All I mean here is that if this side length is 2x, then this side length has to be 3x. So you can kind of imagine, right, if I had a rectangle of, let's say, a ratio of 3 to 5, then this side length over here would be 3x, and this side length over here would be 5x. So 3x and then 5x. So you kind of see, hopefully you kind of see what we're talking about here. So given all this, and given that the area is 150 units squared, I forgot if it was inches or whatever, so maybe go back, check. Yeah, it's inches squared. This tells me that area is equal to length times width. So I know length times width is equal to area. And I know my length is 3x. And I know my width is 2x. And I know that the area is 150 inches squared, right? So 3x times 2x is going to be 6x squared equals 150 inches squared. And then I divide both sides by 6. So you can do that over here. So 6 goes into 15 2 times. 3 comes down, so subtract 15 minus 12 is 3. 0 comes down. And then 6 times 5. So 150 divided by 6 is 25 inches squared. My bad. 25 inches squared. And then if I solve this out, I get x is equal to plus or minus 5. And then we talk about that extraneous solution again. -5 inches doesn't make any sense. So we ignore the negative. And we say that x is going to have to equal -5 inches. Or, sorry, positive 5 inches. We don't want the negative. And then if you look over here, right? We want to find the dimension. So if I look at length, I know that x is 5, so the length must be 3 times that, so 15 inches. And then over here, 2x, so width has got to be 10 inches. And so there are multiple rectangles that we can create to make 150 inches squared. So if you saw 15 and 10 as the dimensions, it was a lucky guess. It could have been, right, 30 and 5. They could have been, so 30 and 5 multiply to be 150 inches squared. So it's ambiguous what the dimensions would be until you work the problem out. Okay, so you got to be careful on, oh yeah, I found the dimensions and it tended to work out. Okay, so I got a few more problems. I think I'm going to leave them for next time. So this will be part 1, and I'll upload this. And then we'll go over part 2 because this is kind of an intensive lesson. So it's already pushing 36 minutes. So I'll edit this one and put it up. So take it easy.